Okay, so you have finished your jigsaw in chemistry, I believe, and you're probably watching this because you still don't feel like you understand periodic trends as well as you'd like to. So we are going to talk about periodic trends. And if I get my yes, okay. So if I get this done, what we are talking about here is periodic trends. Okay, the word periodic means it happens over and over and over again, and the word trends means it's a predictable outcome, that there's a relationship between what happens on a periodic table and the property that we're talking about. Okay, so if you look at this chart, what would be nice if you could actually have a copy of this chart, and I'll talk with the chemistry teachers and see if that can be worked out. This chart talks about atomic radius, ionization energy, electronegativity, and a cation and anion. And I'm assuming you know what these words mean. A cation is an atom that has lost electrons, so it's positively charged. And an anion is an atom that has gained valence electrons and is going to be negatively charged. So if we talk about the trend, the definition of atomic radius is that it's the radius of an atom. That's it. It's the radius of an atom. It goes from the nucleus to the edge of the electron cloud. And the trend on the periodic table as we go from left to right, okay, as you go from left to right, atomic radius decreases as you go across a period, meaning that the atoms are getting smaller. And as you go down a column, it increases as you go down a group. So you ask yourself, why is that so? Well, as we go across a column, the electrons are going to be added to the same energy level. And so what you're doing is the electrons are going in a level that's the same distance away, and as I go across this period, I'm adding a proton to the nucleus each time, so the nuclear charge gets stronger and stronger and stronger. That pulls those outer electrons in closer and closer. So we see this trend as you go across a row in the periodic table for atomic radius. As you go down a column, the atoms get larger and larger. And this one is not so hard to envision. They get larger because with each successive row in the periodic table, you are adding an energy level. So an atom that has 2 energy levels is going to be smaller than an atom that has 3 energy levels. Okay? With ionization energy, this is defined as the energy required to move an electron from an atom. Okay? That's ionization energy, and you'll be talking about multiple ionization energies. I'm just going to start with the first ionization energy, which is the energy required to remove the first electron from an atom. As we go across the row, the trend is that it increases. It gets increasingly difficult. It requires more and more energy to pull an electron away from an atom. As we go down a column, ionization energy decreases, meaning it's easier to take an electron away from an atom. Now, what explains the trend as you go across? The electrons are harder to remove from small atoms because they are closer to the nucleus. Again, remember, as you went up here, the atomic size is getting smaller and smaller. These outer level electrons are getting closer to a nucleus that has got a greater nuclear charge. That makes it more difficult to remove an electron away. As we go down, this again is all about it's easier to remove an electron from a larger atom, and the atoms are larger because they've added energy levels. With electronegativity, this is a measure of the ability of an atom in a chemical compound to attract electrons. We say it's a nucleus's ability to attract shared electrons to itself. And as we go across the row here, electronegativity increases as you go across a period. Why does it increase? Well, shared electrons are closer to the nucleus. Therefore, there's a greater attraction. Again, as we go across, this all goes back up to this piece right here, is that the atomic sizes are getting smaller. That means there's a greater attraction experienced between the nucleus and the outer level electrons. As we go down here, electronegativity decreases as you go down a group. And again, the shared electrons are farther from the nucleus in larger atoms. Therefore, there's a decreased attraction. Okay. With cations, a cation is a positively charged ion formed when an atom loses one or more electrons, and these would be valence electrons that we're talking about here. Okay. And the cations are smaller than the atom from which they formed. So a sodium ion is going to be smaller than a sodium atom. Reason? When I lose electrons, that decreases the size of the electron cloud, which reduces the radius of an atom. If you reduce the radius, you're going to have your outer level electrons then are going to be closer to the nucleus. That makes it a stronger attraction. And this is a little bit opposite here with an anion. A negatively charged ion formed when an atom gains one or more electrons. The anions are going to be larger than the atom from which they formed. Reason? The electrons that you gain are increase the size of the electron cloud, which increases the radius of the atom. I'm farther away from the nucleus. Okay. So, how's that sound? What you have here, I've got a little more text, and if you want to read through these successive slides, what I would do, if you want to get more information about periodic trends for atomic radius, you can read this. You can pause the video and read. If you want periodic trends for metallic character, what makes an atom more metallic or less metallic as you go across, again, as you go across or as you go down. That's your two options here. You can read that. If you want to read the periodic trends for electronegativity, you can read this. You might need to expand that. And this one here for periodic trends for electron affinity. I'm not sure if your teachers are going to cover electron affinity or not, but there's a little bit of information about this property. And then finally, the periodic trends for ionization energy. Here's a brief discussion of that. Okay, so if you've got any questions here, I would bring them back to your teacher, or you can email Chemboy if you want, but I think you'd have better luck talking to your teacher. This final document here is interesting. You're going to probably play around with this website. This is the dynamic periodic table, and one of the things that you can do, I've got properties right here. You can choose different properties. This one is looking at ionization energy. And if you remember what the trends are for ionization energy, this is a different way to visualize that. And I just wanted to open your eyes to this. I know you're going to be working with the dynamic periodic table in class. So that's all I have to say for you here. I hope this is helpful. Good luck, and remember, keep your stick on the ice. Thanks. Bye-bye.